Well, welcome to this PV Tech webinar, part of our Tech Talk series. My name is Mark Osborne. I'm the Senior News Editor for PV Tech. Our webinar today, we're very pleased to have several presenters from different companies, but the whole point is that it's interlinked to a very important issue, which is with the strong migration to high performance modules of a whole range of technologies being adopted. There's a certain need for the quality, the reliability, and the performance factors to be addressed. And we're very fortunate to have three leading experts in this field. We have Jinko Solar with talking about their high performance modules. We have METKA discussing as an EPC their project that was adopting the Cheetah modules, but also they're talking about all the issues that were raised through this. And then, we also have DNV GL presenting on what their requirements are and what people really need to understand about the certification and qualification of high performance modules that have only really been on the market for around a year. So we'll be starting the presentations with Andrea Viaro, who is head of the technical services department for Europe for Jinko Solar. That will be followed by Ruben from DNV GL, who is the head of the organization's solar section in the Iberian and Latin American regions. And then finally, we have a presentation from Nikos Sokos, who is the general manager of METKA for the MEA and continental Asia regions. We also have as well Athanasios Bakalis, who is the group technical director, who will be around throughout the presentation, but will maybe come in at the end during the Q&A and to provide any help there. One final thing before we get going is that because we've got three different companies presenting, if you want to ask a question, the question section is open. You can start putting your questions through each of the webinars, and we'll have a good 15 minutes or more at the end to answer those questions. But to help, if you could put the name of the company first, so Jinko, for example, then we know which person you'd like to answer your question, and we'll try and get through as many as we can. So with that, Andrea, thank you very much.
Thank you, Mark, for your nice introduction. Thanks also for moderating the webinar, and of course, thanks PV Tech for hosting this this webinar today. I would like also to thank DNV GL, our trustworthy partner for testing and testing of PV modules, and which support us on all the activities for a PQP program and qualification of PV modules, and also METKA, which is a long-term valuable customer of us, which is using all the technology that we are presenting today in our webinar. And also thanks also to the audience for attending our webinar today. We hope you will find it useful and kind of new business and to take more fruitful results from your PV investments. So starting with the webinar, with our presentation, we just want to brief quickly on the current facts and figures about Jinko Solar. Yeah, just starting from just two main figures, the global footprint, not only in terms of sales representative office, but also in terms of modules deployed globally. We reached already the 40 gigawatt milestone at the end of last year. The capacity that we deployed, the quantity of modules that we deployed so far globally, so we reached already 40 gigawatts at the end of last year. Modules were deployed globally, which means that we're also qualified globally. It means that modules are possible to be installed in any location, in any climatic condition, in any possible application for PV installations. And the capacity, which last year was above 11 gigawatts of delivered modules, then it will be increased, estimated this year up to 16 or 18 gigawatts, according to the estimations that we have, the roadmap that we have for 2019. And big part, if not all, the production will be a lot focused on mono-PERC technology, and specifically on the Cheetah series, which are becoming mainstream since this year. Going quickly through the milestones that we achieved in the past years since when Jinko was established, we can see, for instance, that Jinko since 2015 is considered as one of the most bankable brands in projects from Bloomberg New Energy and Finance reference. So they not only qualify who is the tier one manufacturer globally, but also in terms of bankability. In this case, in terms of financial bankability, which means which is a reference and an identification of the manufacturers in terms of financial strength and how trustworthy and stable, financially speaking, is the manufacturer or the supplier that you use for your project. Another very important reference is what we achieved, actually not in 2018, but in all the 4 editions of the PQP qualification program from DNV GL. Jinko Solar was qualified as a top performer in all the tests and with all the technologies, all the samples that were provided for the program for the testing. And that's really probably even more important than the bankability reference given by Bloomberg, because it gives an idea of the technical bankability of the modules, which is directly related to the quality of the products that Jinko supplies. Other 2 important milestones which are implemented then in the Cheetah series is, of course, its launch, which happened last year in 2018. So after its launch in SNEC China last year, it was rapidly growing in terms of market share, and now it's becoming mainstream this year very rapidly. And also the hot cell mass production, which was launched in 2017, beginning of 2017, which is included in the Cheetah solution, in the Cheetah products, as a best fit to increase even further the peak power of the module and to achieve the highest possible performance for the PV plant. So here summarized and graphically visible the ranking that we achieved in terms of volumes delivered. So we rank, Jinko Solar ranks as at the highest level in terms of bankability, according to Bloomberg New Energy Finance, in terms of bankability for PV projects, clearly. And also in terms of capacity, Jinko Solar still owns the leading position in terms of volumes produced and delivered so far, and hopefully that will be the same for this year, clearly. As I mentioned, nonetheless, the bankability qualification that Bloomberg gives is focused mainly, if not only, on financial bankability. So this is a very good achievement. It's a very important reference that gives confidence to the market and to the developers and our partners when it's time to decide which brand to use, but it doesn't give an idea about the quality of the modules. To that extent, a very good partner that we use very often is DNV GL, thanks to the program that they developed, which is named PQP. So known in the industry as a reference, which is becoming really a reference in parallel to the IC certifications and the UL certifications, because we clearly understood that that is not enough, and to give a more accurate and reliable evaluation of the quality of the PV modules and the durability of the PV modules, it's really important to go beyond the IC certification. And that's an evidence of the technical bankability of the PV modules that Jinko produces and delivers. And we will see later, hopefully in the presentation from METKA, how this document, for instance, or this protocol was one of the key the key elements for the success of the financing and the security financing for the project that they are developing now in Spain. And so in this case, the PQP for us is a very important tool to support Jinko when and the partners that we have, like METKA in this case, to support us when it's time to do due diligence or qualification of PV modules. First of all, because DNV GL, of course, is a third party and trustworthy globally and recognized PV laboratory. So in this case, as an independent body, it's possible to rely on the evaluations that they do to make sure that the quality of the modules is really what we promise we will deliver. All these effort, all these achievements in terms of bankability, financial, but more importantly, about technical bankability, are of course achieved thanks to the investments and efforts that we put on R&D activities. So we have clearly an internal R&D department. We dedicated facilities for research on wafer cell and modules, for covering the whole value chain. But not only, we cooperate externally with very well-known laboratories and research institutes to support us on basic research and the possibility to implement in mass production the achievements that we get at R&D level. Because more important than having technical concepts possible, which are boosting performance of PV modules farther and farther, the real challenge for us is always to make them viable in mass production. So the real challenge is not only to achieve peak power records for PV modules and PV cells, but really to be able to deliver and produce gigawatts of those high efficiency PV modules and to make them technically bankable above all. So all these R&D efforts allowed us to smoothly and successfully achieve the transition, for instance, in the shift from technology to technology. For instance, in the past years, we moved from polycrystalline to monocrystalline, not only Jinko, but the industry as a whole, thanks to the developments achieved at R&D level and in production, more importantly. And now, for instance, with the Cheetah series, moving from mono standard and mono PERC to the Cheetah series, which is a larger cell module, even more powerful than the traditional module size and mono PERC technology that we were using until 2 years ago, and allowed us to really successfully and smoothly move from one technology to the other, and to allow the market to accept that, to make it bankable and to make it acceptable and successful in the real deployment of the technology in the PV field. All these achievements and R&D are, of course, focused on cell efficiency, module efficiency, which represent the power of the PV module. So we know that all the R&D activities are always focused to increase farther and farther the cell efficiency and the module efficiency. But when it's time to talk about LCOE, it's very important to focus on the fact that not power is probably the main factor which plays a key role in the LCOE level, but durability, first of all, is key to have a stable energy yield, a stable performance of the PV park, a stable performance of the PV module. That can be achieved, of course, thanks to our internal R&D efforts, but also thanks to the partner and the quality material that we use in production. Talking about the components like the backsheets, the silver paste for the screen printing of the cell, even down to the connectors that are used at the output cable. So we select and qualify all the best suppliers for production, which allow us to deliver the highest quality possible modules to our customers. Because we know that when it's time to talk about LCOE, module efficiency, of course, reduces the BOS costs. So it has a direct, very high impact on the BOS cost reduction. But on the long term, reliability and durability is the most important parameter to achieve the lowest possible LCOE and the most profitable return on the investments that you do with your PV park. And we will see that later, especially in the comparison that METKA did when they evaluated the possibility to use our Cheetah modules compared to the previous technologies and the old technologies that were traditionally used until now. But let's look into detail about the Cheetah series and how these modules are different compared to the previous technologies that were constructed and supplied before 2018. So the Cheetah modules is basically standard PV module based on 60 or 72 cell format. It's possible to combine it also with the house cell technology, as I mentioned before. The main difference compared to the previous series of monocrystalline modules is that the size of the cell of the wafers is larger, and that's slightly larger, and that allows us to increase the peak power of the module, the power class of the module, but keeping the size and the dimension of the modules still in a limit which is viable for the EPCs, for the designer of the PV site, to not dramatically change the construction of the PV array, which is key to control the BOS cost, to reduce the BOS cost instead of increasing that, because making new design, making new mounting systems or new solutions for racking modules, then it would have the counterproductive effect instead of reducing the LCOE level. And by doing that, by increasing the cell size, we can increase 1.5 power class at module level, and by combining that with the house cell solution, we can increase in total, compared to the previous mono-PERC solution, mono-PERC technology we used before, up to 3 power classes higher. So we can increase significantly, as you can understand, the module peak power, and then directly, as I mentioned before, reduce accordingly the BOS costs. The Cheetah series PV modules also allowed us to keep a steady increase on module power class, starting from its launch in 2018, and then year over year we increase 1 to 2 power class on the module power, so to further reduce the LCOE, to further support the increase in profitability of the PV investments, and to make it profitable, of course, for our partners, for our customers that will use the technology. We wanted to make an estimation of comparing the different solutions, different technologies that can be used in a PV park, and of course comparing them with our Cheetah technology. We have in this chart on the right hand side the traditional poly standard solution, and then on the left hand side the mono standard solution. So you see that, of course, by increasing the power class of the PV module, you reduce accordingly the BOS cost, and that's because, of course, you need less components, you need lower labor costs to construct the PV system. This is an estimation of a plant of a few tens of megawatts done in Spain. Of course, that's an estimation, but it's easy to understand how reliable is the estimation. It's done with PVsyst, of course, design tool, and which is a reference also in terms of bankability, and of course not only Jinko but all the partners, all the customers that we work with also rely on the same reference. In terms of energy production, clearly the fact that the Cheetah series uses a mono PERC technology increases a lot the energy yield, because the efficiency of the module is dramatically increased compared to the mono standard technology and the poly standard technology. So in this case, also in terms of energy and performance of the PV park, we have a very direct benefit ultimately on the LCOE, which is a combination, of course, of different factors, but taking into account the two factors mentioned before, which are BOS and energy production. We can see very easily how it's possible to achieve the very lowest LCOE possible level using a Cheetah and a Cheetah house cell in particular technology, as we discussed so far. So in terms of reliability and durability, we know that that is a key as a conclusion to achieve the lowest possible LCOE and to have a stable and highest possible IRR, return on investments, that you can achieve. The combination of the Cheetah technology and the house cell increase the module peak power, and we can achieve already today the 400 watt peak module. 400 is already a mainstream product, as you will see in the project developed by METKA in the next presentations. And thanks to third-party qualification program like the DNV GL PQP program, we can support our customers and the market with independent and real aging condition tests, which go beyond the IC certification, which are key to really qualify and make sure that the modules quality is really what we want to have in the field at the end. And of course, when we talk about LCOE and bankability, we know that the importance of field-proven materials is key, and in terms of selection of the components used and optimization of the production processes, especially when we have to apply modules in harsh climatic conditions and with very high temperature conditions, which are very aggressive for the PV modules. So as a very conclusion, technical bankability and financial stability of the supplier that you choose for your PV project are key. Proven field track records are also important to secure the lowest possible LCOE and the highest possible IRR. I conclude my presentation here then, and I leave the floor to the next speaker.
Yes, thank you very much, Andrea. That was very interesting. And again, just to reiterate that if you questions put forward, we'll come back to those at the end. But also, sorry for the noise. I didn't invite any children or dogs to come into the webinar. We don't know what happened, but we were able to just block that out. So once again, apologies to everybody. We did know what was going on, but it just appeared out of the blue. Our next speaker, now that we don't have any interruptions, is Ruben Ron from DNV GL. So Ruben, over to you.
Thank you, Mark. Thank you all. First, let me also thank the PVTech and Jinko Solar for this opportunity to participate on this interesting webinar and share some of our knowledge and experience on this topic. Our global reach and density of offices around the world is a factor that enables us to take a broader view. Our 30,000 employees over more than 100 countries pride ourselves of having the same high standards wherever you meet us around the world. DNV GL has 5 business areas. With research and innovation, we is a fundamental part of DNV GL supporting foresight, insight, and service innovation for all 5 areas. The merger of DNV GL was the first consolidation among the global classification societies, but each of these 2 organizations had also consolidated their positions within the power transmission and distribution sector with KIMA, the renewable energy sector with Garrahan and KIMA, and oil and gas with Noble Delton and Atlantica. We provide support through the whole project life cycle. Our services are tuned to meet power requirements and expectations for ensuring a proper accomplishment of their goals. Within our service portfolio, we offer independent and owner's engineering services since the project inception and becoming reliable partner for any technical assistance needed in any project phase. We have supported more than 6,000 projects worldwide, and the PV module scorecard, prepared together with our colleagues from PVL, has been used by more than 4,500 players for supporting their investment decisions. Also, at this moment, we are monitoring more than 10 gigawatts, in fact, close to 15 gigawatts of solar PV plants through our colleagues of GPM, Green Power Monitor, company acquired by the group in 2016. Moving to the topic of this webinar, at this moment, the solar module market is dominated by the traditional aluminum back surface-based cell technology. However, over the next few years, the commercial choices available will significantly increase, which will make more complex the decision process for project stakeholders. To name a few, half-cut cells, PERC, bifacial, GHT, IBC, and the latest thin-film developments are trends that could be considered for utility-scale projects in the very near future. The main targets for all manufacturers are increasing performance, reliability, and durability at the same time that the manufacturing cost has reduced. Half-cut cells, which are traditional cells that has been cut in half using a laser cutter, try to reduce resistivity losses and higher shade tolerance, as well as improve resistance to crackling. PERC technology, based on the seems to be one of the most powerful trends for increasing module performance. This technology is expected to increase in market share from 14% in 2016 to more than 40% in 2021, and even replace almost all aluminum back surface field production by 2027. Bifacial technology is moving fast to reach commercial viability. In fact, many EPC and developers are already considered for the upcoming projects. An increasing energy gain between 6 to 15% compared to previous technologies is a strong reason to take this option into account when evaluating the technology to be implemented in a project based on site location and the albedo. As a result of the higher power production and falling cost, the LCOE could become lower than standard options in the short term. But the new technologies and new trends also bring challenges to be considered in the path to become commercially proven and being accepted by project stakeholders. I try to include in this slide some of the most relevant challenges the industry is facing to launch the half cell, PERC, and bifacial technologies into the utility scale market. I would like to highlight some of them. First, new materials are being introduced as well as additional steps to the traditional manufacturing processes. This fact is not necessarily a risk challenge itself, but introduces the need to review certain aspects for verifying the bankability of the process as certifications and the quality assurance system. Regarding the light and elevated temperature induced degradation, LETID, the impact of this on a module in the field can be both significant and also unpredictable. Although researchers have announced that both multicrystalline and monocrystalline PERC modules can degrade severely up to 50% when exposed to both light and temperatures above 50 Celsius degrees, it seems more appropriate to consider degradation rates up to 5%, which in any way could have a significant impact on LCOE and investment and return on investment of a project. Manufacturers are already announcing LETID suppression strategies, whose effectiveness should be reviewed, as well as the result of lab tests at elevated temperatures and light exposure and long-term field data. As technical advisors, we always recommend considering a solar resource measurement campaign during the project development phase. But for bifacial technology, for example, it is even more important due to the necessity to characterize the albedo. Another important challenge for these new trends is the lack of fully developed testing standards for both LETID process and the rear side generation for bifacial. Also, as technical advisor, our customers expect from us to provide accurate energy assessment estimates, as well as well-defined uncertainty levels for the long-term estimate. Considering the lack of validation of current simulation tools, as well as other difficulties in the simulation process, the challenge to meet customer expectations is significant. And finally, the limited field experience at this moment is one of the most important challenges to be overcome. Manufacturers and research centers, as well as other relevant players in the industry, have to collaborate closely to make operational data available as soon as possible. In order to overcome this situation and lay the foundations to reach proven technology status and be accepted by industry, we have identified some mitigation measures or initiatives. And would like to highlight the need to close collaboration within the manufacturers for accompanying the new development since the beginning, gathering useful information, for approaching the industry and getting back that could be considered in the next step of developments. Well, how does DNV GL approach the analysis of PV technology during the technical due diligence process? Well, we are nowadays analyzing the implementation of a new procedure to associate a specific PV component, in this case, for example, a PV module, to one of these categories based on clearly defined requirements and considerations, as stated in the slide, as well as the level of review required for reaching each of these categories, a bankability review, a full independent energy review, or a fatal flow review. Risk level and mitigation measures will be associated with each category to be provided to our customers. At this moment, we are even analyzing the potential impact that could be associated to each of these categories, mainly for the qualified and new technology options in the energy estimates, for considering the increase of uncertainty derived from non-proven technology. Finally, certification is being considered as main approach for quality assurance, but even 35 modules can fail. For example, from 2012 to 2018, DuPont performed extensive field inspections over 1 gigawatt, and issues were detected in approximately 22% of the modules. In 2012, DNV GL developed the PV module product qualification programs mentioned before by our colleague from Jinko, to support the solar community with two aims. One, provide PV equipment buyers and power plant investors with independent and consistent reliability and performance data to support implementation of an effective suppliers management process. And second, provide independent recognition to module manufacturers who outpace their competitors in product quality and durability. At the end of last year, DNV GL with our colleagues from PVL had tested over 300 bombs from over 50 module manufacturers. Modules are randomly selected, and bill of materials of modules submitted to PQP testing are witnessed in production and tested in the same way, on the same equipment, in the same environment to enable a level comparison. Extended testing process is performed beyond the IEC standards requirements, and based on the result of the program, as well as field experience, DNV GL defined best practice for ensuring the quality of modules purchased for a specific project. In that sense, there are questions that have to be asked to ourselves during the different phases of the project. Do we believe in the project and the product? Do we believe in the manufacturing process? Do we trust the transportation and installation processes? It is important to have answers for each of these questions and apply the appropriate measures to ensure the quality of our products and projects. Answers that can be supported by bill of materials and manufacturing facility qualification through the PQP program at the beginning of the product life cycle, factory audit at the beginning of the production, factory oversight and statistical batch testing during the production, ER luminescence inspections on site during the project construction, and even thermography and ER inspections during the project operation to keep following up the module performance. All these best practices get even more importance when new trends and technologies are getting closer to the commercial point and considered for utility scale projects. Thank you for your attendance, and happy to answer any questions you may have at the end of the presentations.
Thank you very much, Ruben, for that. Our next presenter is Nikos Sokos from METKA. Over to you, Nikos.
Hello, everybody. Thank you to PVTech for organizing, the attendees for being here, and our dear colleagues from Jinko and DNV GL for their presentations. Together with Mr. Bakalis, our Group Technical Director, we represent METKA EGN, global leading EPC contractor, offering solutions for utility scale PV plants and hybrid power projects. We have now installed operational 700 megawatts of projects, and by the end of the year, we're going to have another 700 megawatts completed. One of those is Here are some references. I'm going to be speaking about number 6, Talasol project of 300 megawatt in Spain, and the use of Jinko Cheetah modules in that project. The challenges in this specific project were mainly down to the terrain being very undulating with high slopes and some rocky areas, and also not the best you could possibly find. So we decided to very early on, after initially designing with 340 watt modules, to switch to 400 watt peak modules to reduce the land used and take advantage of the much promised high performance, let's say, benefits. So what we need to do was to maximize the density of the installed power, to minimize the ground coverage ratio, and be able to use single axis tracker with a minimum axial distance. Here's a small snapshot of the two plots. You can see in the pink colors the slopes between 12 and 15%, and in the blue color the slopes equal to or above 15%. Again, stressing the need to be power dense in this project. Here's a small comparison in some key areas between the initial design with 340 watt peak modules and the final design with 400 watt peak modules. You can see a reduction in the used area, a reduction in the fence length, a considerable reduction in the modules used in terms of pieces used in combiner boxes and in trackers. So having less deliveries and less installation to be made. Also now to stress how the technology advancements mentioned by both Jinko and DNV GL are now proven through PV system analysis. We had an improvement in the produced energy and lower losses due to temperature and lower losses due to using the more efficient 400 watt peak module. To sum up, the new module, the Cheetah half cell PERC, offers higher efficiency, lower degradation over the life cycle of the project, so better performance in the long run for the owner, better performance under high temperature, which for the specific project during the summer with temperatures up to 40 degrees, it's helping a lot, and also minimizing the near shading effect through the half cell technology. In this case, LCOE was slightly improved, but okay, this is a case study we'll explain more later. Now, the considerations that we had to take into account when choosing these were the benefits, yes, and the considerations that we take into account was to balance the lack of proven track record, because the Cheetah module by Jinko was introduced only 2018. The owner's engineer and the lender's TA had both to approve and to, let's say, consider the solution offered. What we did in the end, in collaboration with all project stakeholders, was to have extra tests beyond the IEC standards and extended product warranties offered by Jinko in order to get the solution to be bankable, which means accepted by both the owner's engineer and the lender's TA in the end. And some of these tests are presented here. Then to conclude and to show the connection between the previous presentations and a real life scenario, in this case of Talasol project, all the benefits of the higher performance models were proven: better ground coverage ratio, less deliveries, being able to avoid areas that are problematic for construction, better module efficiency, more yield, better performance in high temperatures, reduced degradation over the life cycle of the plant, slightly lower LCOE, bankability, by collaborating with the third-party advisors, owner's engineer and lender's TA, and whatever increase was in the price of the modules was in the end almost counterbalanced by the improvements in the BOS cost. And finally, to stress the importance of how an EPC nowadays has to be placed in a way to be part of the ongoing technology discussion with all the stakeholders, project by project, case by case. Thank you for listening.
Okay, thank you very much, Nikos. We have plenty of time for Q&A, so that's a good bonus. A couple of quick ones, I think, if we can start with back to Jinko with you, Andrea. Several people have been asking various performance aspects to the Cheetah series module. For instance, with the half cut module, what's the on the half cut Cheetah module, what is the actual module conversion efficiency?
Yeah, let's say with the half cell solution, the main difference is that, of course, we increase by 1/2 power class at the module level. So the efficiency is, of course, increased accordingly. But the main difference is really at module level, even given the same cell efficiency, is the possibility to increase and to boost the power class of the module by 5 to 10 watts. Let's say 8 watts, 7, 8 watts on average. So there is not an absolute answer for the cell for the module efficiency, because it depends on the power class of cell that we use. But the answer is exactly this: the possibility to increase a power class up to 2 power classes at module level, thanks to the different half cell configuration compared to the full cell solution.
And of course, this has all been driven by the use of oversized large area mono wafers now, and so therefore having half cut cells, half cut modules is all about reducing resistivity, and that boosts the overall performance. Totally
true. And actually, it seems like a contradiction, but of course we do larger cell and then we cut them in 2 pieces, so it looks like a kind of ironic. But the fact is that by increasing the cell size, of course, we increase proportionally the cell current. And by doing that, the risk is that the cell current can really exceed the acceptable level in case of any hotspots or any critical situation, in case of very high irradiance conditions. So in this case, a half-cut cell module, it's really needed, especially moving above 400 watt peak module, because as I said, the resistive losses that could happen in partial conditions like shading or soiling, then it could lead to some excessive losses or some critical conditions for the PV modules. So yeah, for very high power class modules, it's highly recommended, and that's the direction Jinko is going for high power class modules, so half cell.
And have the Cheetah modules actually been tested with under the DNV scorecard system?
It's still ongoing. The PQP program is a very nice program, very complex. The only disadvantage is that it takes a really long time to be completed. It takes almost half a year to go through the complete sequence of tests. And that's a problem why we still don't have a final report on that, but it's work in progress, and it should be available very soon.
Excellent. Sticking with the issue with reliability, another question came in about the Cheetah series in general, which is related to high temperature environments, especially sort of 40-degree plus, so equator type of regions. Now, obviously, you can have desert conditions on the equator, or you can have very hot and humid jungle conditions on the equator. So the question being there is, how do these modules perform in those environments?
That's a very complex question. Actually, there is 2 aspects, as you mentioned. One is temperature, one is humidity. Regarding temperature, of course, temperature coefficients of the PV module, of the PV cells, are really playing the key role in terms of performance. So the Cheetah half cell series for Jinko has the lowest, the most advantageous temperature coefficients, especially thanks to the monoPERC solution at cell level and the half cell configuration, which improves the packing factor at module level, therefore allows to minimize the thermal losses thanks to the improved temperature coefficient. So even in very high temperature environments, it's really possible to maximize the performance of the PV modules also in these conditions. In terms of humidities, humidity doesn't affect the performance directly in terms of power or efficiency. The challenge when it's a very hot and humid environment is in terms of durability and of the laminate. So to that extent, the laminate components play the key role, especially the backsheet, and that's the reason why we mostly or almost exclusively recommend the tabular-based backsheet for the modules, and that's the main material, the main component that we use for our modules, because it's still proven after many tens of years of operation of PV modules in the field, is still the most field-proven material that can be used for a PV laminate.
Right, understood. I've had quite a flood of questions coming in, but there was just trying to move. I'm not sure. I actually this is for METKA. The person here is asking why state a lower degradation over time for Cheetah versus Poly if the module is only in production since 2018, and they're saying there's no data on that. Bear with me a sec because I've just lost it. So why state a lower degradation over time for the Cheetah module versus a Poly module if the module is only in production since 2018 and no proven field data is available yet, plus the new issue of LETID being available impacts the degradation over time severely. So I don't know how you want to address that one, but I think from your presentation, Nikos, there's a lot of collaboration and demand for extra data from people like Jinko on their module performance that enabled you to use these advanced modules when obviously the bankability factor of these could be limited.
Well, it's exactly as you say, Mark. The collaboration was both very close with Jinko and with the third-party advisors. And yes, there is no proven track record per se, as of yet. It is what we expect the module to perform like. And this is exactly why the extra tests outside of IEC standards were introduced. Also, along with the extended product warranties that Jinko has offered. Maybe this was a parameter not stressed enough, that the bankability was not only due to the technical parameters of the panel, but also to the support behind the panel by Jinko itself.
Understood. Maybe if I can bring in Ruben here. Obviously, people are concerned about lid and LETID and PID issues. In your experience with the testing, especially like with the scorecard, these things need real rigorous methodologies. But it was interesting that you said the company overall has tested modules of more than 50 companies. But is the trend for things like LETID, PIDs and everything else, is the trend that people are solving these issues? You're failing less modules because of these issues, because people are starting to tackle them in a correct way?
No, I was saying that based in the results from the testing, obviously the degradation and rates were more significant at the beginning when these phenomena started at the beginning. Just after the production starts, and many manufacturers are investigating with research centers in order to introduce suppression tools and strategies in order to avoid this kind of problems. For example, or one good example is the PID, where at the beginning was like a real problem after the industry develop a solution for that specific degradation issue. Now it is almost no problem at all, and we expect to see similar evolution for the LETID to these PERC modules.
Understood. Keep you on there for Ruben, because there's another question here, I think, for you, although it's, it could be applied to anybody here. Although in some places it's a regulatory issue, for instance, with utilities, but how do you get away, or how do you get around the fact, say, let's use the issue with bifacial modules, is that there's a lot of unanswered questions about the performance, how you even go around about the measurement of bifacial modules, and a question here really is that this is leaving, developers. This is a person in Canada saying that this developers' uncertainty as to how to rate bifacial systems or PV power plants with bifacial modules. Are they using STC or BSTC? What's an appropriate measurement here? And I think we both know that it's an ongoing topic. The more we learn and understand about bifacial, one, we're seeing that there's more performance availability, but obviously the testing is still going, it's still moving on.
Yeah, absolutely, totally agree on that. And in that sense, we are collaborating through a project we have with several manufacturers in US in order to perform testing and get operational data, because it is the best way to get or to reduce these uncertainties that we are facing at this moment. We have developed internal post-processing tools in order to make our estimates, energy estimates, more accurate, but there are still room for improvement. And this project we are collaborating in US for sure will bring some clarity on this topic.
Okay, great. Shifting back to the modules, the module side. What are the this is for Andrea, what are the extended product warranties for Cheetah?
Actually, the Cheetah modules are of course supported by the standard limited warranty conditions that Jinko provides. Of course, we can offer in specific cases slightly improved conditions depending on the evaluations that we have for the specific project. But in general, the Cheetah series, as it is a mono-PERC technology-based solution, then it's based on the annual degradation, which is limited to 0.7% year over year. And then for the first year, we have a maximum 3% reduction in module power.
Right. One back for Nikos here, and again, I think this has been is a genuine theme across the board with new technology. But once again, a question asking, basically how do you convince the banks or the investors that the new technology, that using new technology is safe to do? And that avert the cautionary approach. So are the technical advisors and developers, what are they doing to increase confidence in the new technology? I think you've answered some of that, but it's just a good point that to reiterate maybe what you had to do to convince the investors that using modern technology, using the leading edge available was the right thing to do, and I believe you had to get somebody on board that was a third party advisor that needed persuading. Maybe give us a little insight into that scenario.
Athanasios will answer this one. He's better placed to do so.
Okay, hello from my side. In general, as Nikos concluded in his presentation, it was site-specific for this specific project, taking into consideration all the circumstances, the field that we had to use, and together with the fact, with the support of Jinko, that the technologies used in the half-shelf mono-PERC module are actually established technologies. Monocrystalline is a technology used in the last years, and with the support with the extra testing in order to prove that the product, the half-shell product, is a bankable product. Actually, what we did with Jinko is we agreed in order to perform more tests outside IEC standards with more mechanical stression. So in this aspect, it was clear from our side, in our collaboration with Jinko, that we really believe the product. And adding all the benefits that were for this site, especially based on the site, the field and the ground conditions, and the need for extra density, this was by itself one huge point from our side to convince, in order to convince the investors and the lenders. I think it went very well because we all had in our mind what is the best selection of the product for this project, and the result was, as we discussed, that we all agreed that this is the way to go.
And I think, correct me if I'm wrong, that with this project, once completed, operational, and you've got data, is that then enough for the use of this type of technology for other projects? You're not going to have to go through the same kind of process, or perhaps with different investors, they'll still want, you know, something done, you know, something else shown. It's just interesting to know how you feel that works.
So back to me, Nikos. What we did not mention either from our side or from Jinko Solar side is that even though possibly in Europe is not so widespread, this new Cheetah module, in China last year there was an implementation of some gigawatt. So by end of 19, it won't be just our project. Okay, our project comes online mid 2020, so obviously for us it can be a big argument in future projects to convince stakeholders. But by that time, there will be live projects in China operating for a year at least by the end of 2019, offering more and more data as we go along. So it will be more or less the case as with every new step you have taken in the last years. Like around 4 years ago or 3 years ago, it was the 1500 volt debate. No, but by now this is let's say a given. Nobody asks any questions anymore about the 1500 volt versus 1000 volt. It's a given in the industry. Then the next let's say debate was over the single axis trackers and how durable they are, especially moving to 2-panel portal configurations. This was also, let's say, now a given after many discussions and data coming available. So in our mind, by the end of the year maximum, this high performance modules, Cheetah or the similar, would be a main technology option based on performance, actual performance on site.
Understood. Thank you very much, Nikos, for that, and thank you all for presenting here today, and all of the people attending. That is the end of this webinar. And just a final note from myself, we will be making available, you will be notified that the presentations will be available for you as soon as we can organize that. So once again, thank you very much all for attending. Bye-bye.